Yes, let us continue the chapter solutions. Today I am going to start the topic constant boiling liquid mixture. We call such type of mixture as azeotropes. In Greek, azeo means boiling. So some liquids, when you mix it, you will get the mixture called the azeotropes. You can say they are the binary mixture having the same composition in liquid and vapor phase. So what it is the binary mixture means mixture of two liquids having same composition in liquid as well as vapor phase. And second is that they boil at constant temperature. So how can you define the azeotropes? The type of liquid mixture which boils at same temperature and having same composition in liquid as well as vapor phase. We have two types of azeotropes. One is minimum boiling azeotrope and the other is maximum boiling azeotrope. For first, minimum boiling azeotrope. So these are formed in case of binary mixture, liquid mixture, which show positive deviation from Raoult's law. Okay. Their vapor pressure is higher and boiling point will be minimum. So when you mix two liquids, they will show the positive deviation from the Raoult's law and they will have high vapor pressure and minimum boiling point. So this mixture is known as minimum boiling azeotrope because the partial vapor pressure of the two components in the mixture is maximum while the boiling points are minimum. Example, ethanol whose boiling point is 351.3 Kelvin and water 373 Kelvin, they make the minimum boiling azeotrope mixture. Example, constitute a minimum at the azeotrope composition. When you mix it, the boiling point becomes 353.1. Okay. So this is minimum boiling azeotrope. I hope you have understood. Then second is maximum boiling azeotrope. Second type of isotope. So when you mix the liquid and it shows negative deviation from the Raoult's law, then you will say this as the maximum boiling isotope. Here vapor pressure will be less, that is minimum, and boiling point will be maximum. Okay, so such a mixture is called maximum boiling isotope because the partial vapor pressure of the two constants present will be minimum and the boiling point will be the maximum. So example, HCl whose boiling point is 188 Kelvin and water whose boiling point is 373 Kelvin forms a boiling mixture whose boiling point is how much? 383. So you must know the examples, and this is also an important topic. Questions are asked from this topic also. You see this chapter, maximum topics are very important. Now next, the most important topic that we are going to study is colligative properties in this chapter. Very important. There are 4 colligative properties, and from this any of this property you will get one numerical, it is sure, in the board exam. So very important, note it. In this all we have numericals also. Numericals is more important. Okay. So what is colligative properties? Colligate means to bring together. Okay, so when a non-volatile solute is added, what will happen? You know that vapor pressure of the solution decreases. We have studied before. So addition of non-volatile solute, what happens? Vapor pressure decreases. So there are many properties which is connected to this decrease in vapor pressure or lowering of vapor pressure. Okay. So first colligative property is relative lowering of vapor pressure. Then second is elevation in boiling point. Then third is depression in freezing point. And fourth is osmotic pressure. So all these properties, they do not depend upon the nature of the solute but the number of particles. Note it, number of particles. So the property of the solutions which depend only on the number of solid particles but not on the nature of the solid particles are called as colligative properties. So let us study one by one the topic. First is relative lowering of vapor pressure. Relative lowering of vapor pressure. So when a non-volatile solute is added to the solvent, the vapor pressure of the solute decreases. You see. So let P1 be the vapor pressure of solute. X1 be the mole fraction of solvent. Then P1 naught be the vapor pressure of pure solvent. X2 be the mole fraction of solute. Okay, so according to Lorentz law, you know that P1 will be equal to X1 into P1 naught. Okay, so we have to find out the relative lowering of vapor pressure. So let the reduction or the relative lowering of vapor pressure be del P1. So we can say del P1 is equal to, here pure solvent, the vapor pressure is more, so subtract it with P1. Partial. So what we see that the vapor pressure of the solvent P1 will be less than that of the vapor pressure of the pure solvent P1 dash dot. So putting the value of P1 here, del P1 is equal to P1 naught minus X1 P1 naught, or we can write so let us continue this. That is del P1 is equal to P1 minus X1 P1 naught, or we can write del P1 equal to P1 naught 1 minus X1. You know that X1 plus X2 equal to 1. So X2 will be equal to 1 minus X1. So put the value of this as del P1 naught equal to del P1 naught. This will be what? X2. So we can equate the two equations before we have written P1, del P1 is del P equal to P1 minus P1. So equate this equation with P1 naught X2. To cancel this P1 naught, you can divide it by P1 naught on both sides. So what you will get? P1 naught minus P1 upon P1 naught is equal to X2. So this is the equation for relative lowering of vapor pressure of the non-volatile solute. You know that X2 is equal to N2 upon N1 plus N2. So instead of X2 you can write here N2 plus N1 plus N2. So here N1 will be what? N1 will be number of moles of solvent and N2 will be the number of moles of solute. For dilute solution, if N2 is less than N1, very very less than N1, so denominator can be N2 can be neglected. So the equation will become now equal to N2 upon N1. Now for N2 and N1 you can write what? N2 as W2 upon M2 and N1 as W1 upon M1. What is W2? W2 is the mass of the solute, W1 is the mass of the solvent, molar mass of solvent M1, and M2 is molar mass, the molecular mass of solute. So this equation now becomes P1 upon P1 not upon minus P, this equal to W2 upon M2 and W1 upon M1. You will write it as W2 into M1 upon M2 into W1. So what is P1 not here? Vapor pressure of pure solvent. P1 is vapor pressure of solution. M1 molar mass of solvent. M2 molar mass of solute. W1 mass of solvent. And W2 mass of solute. So if all the values are known, you can find out the molar mass of the substance. Okay, so this equation will be used for the numericals. So let us do one numerical. I hope you have understood this topic, that is relative lowering of vapor pressure. So one numerical we are going to solve, that is a solution is made of dissolving 30 gram of non-volatile solute in 90 gram of water. It has a vapor pressure of 2.8 kilopascal at 298 Kelvin. Vapor pressure of pure solvent is given as 3.64 kilopascal. Calculate the molar mass of solute. So you have the formula P1 naught minus P1 upon P1 naught is equal to W2 into M1 upon M2 into W1. So here what is given? W2 is equal to 30 gram, W1 is equal to 90 gram, P1, this is equal to P1, and vapor pressure of pure solvent is P1 naught. So just here to find out what is M2. All the things are given. 3.64 minus 2.8 upon 3.64 equal to 30 into 18. M1 is 18. Not written here. M1 is 18. Water is given. Then M2 into 90. Or M2 is equal to 30 into 18 into 3.64 upon 90 into 0.84 equal to 26 gram per mole.